All right, so welcome everybody to this first edition of Orbit online sessions, which at the same time is a Google Developer Group meeting. Before we begin, I will ask all of you to turn off your cameras, those of you who haven't already, during the talk, and we can turn them on again for the Q&A session later on. So this meetup was supposed to take place in March. However, due to the coronavirus situation, we had to reschedule. So we're very happy that our speaker, Filip, agreed to test this new format with us today. So, my name is Lide, and I'm the community manager here in Orbit Lab. And also here with us today is Kasper, the man with the many titles, ranging from Orbit Lab commander to professor at Aarhus School of Engineering, and organizer of this local Google Developer Group. So you'll get to meet him in just a second. The program for today consists of two parts, a tech talk and a Q&A part. And as this is the first time Filip has done this online, these two parts may be longer or shorter than estimated. In any case, we plan to finish around 5:45. So questions. If you have any questions that are urgent, you're welcome to post them in the chat function, and I'll try to keep an eye on them during the talk. However, if your questions can be saved for the Q&A session, please save it for then. So before I hand you over to Kasper, I can tell you that Filip's slides will be distributed after this session. And I also want to make you aware that we are recording this talk. And of course, we encourage you to follow Orbit Lab on social media of your choice to keep up to speed with what's going on. We do have a couple of more online events coming up in May, which will be announced on these channels. So all that's left for me is to hand you over to Kasper.
Thank you, Lida. So I don't have any fancy slides or anything. I just wanted to say welcome. It's been quite a while since we had the last Google Developer Group Aarhus meetup. And with the new situation that we're all in, it's probably going to be a while before we see each other physically. But we have, we do want to do more online events like this. Obviously, we can have a broader reach. It's a little easier for you to attempt the talk after school or after work. So hopefully we can actually make it even better. We can have more talks, shorter talks, and also we don't have to source as much food to feed all you guys. So hopefully you got your own snacks ready at home. And then I just want to give a kind of a call out. In the organizing group around Google Developer Group Aarhus, we would really like to have more people step up and either come and give a talk or say like, I wanna be part of this. I wanna help organize cool techie talks and events. So please reach out if you have any ideas for people who want to speak, preferably yourself or somebody you know. And also, if you want to help organize and make this community even more vibrant and alive. And then, without taking too much more time, I would like to introduce Filip, who I usually meet only once a year, or maybe twice if he comes and gives a talk in GDG, but we used to meet at the Google I/O conference in California, and unfortunately this year that was canceled as well. So, but this will be the next best thing, and I know I've heard Filip quite a few times before, and he's an excellent speaker, and he's extremely knowledgeable about web technologies in general. But Angular and web components are very dear to his heart. So I'm very excited to hear what's the kind of state of the art in web components and why we should be more excited about it. And I think, Filip, you can say a bit more about yourself and your background.
Sure. Should I just take it from here?
Yes, that was what I implied.
That was your cue.
That was your cue.
Great. So, do you see my slides?
Yes.
Excellent. So great. Thanks for having me again. It's always good to be here, even though it's only virtual this time, but it's a lot of fun to be in my hometown. I'm super excited about web components, and I can't stop talking about them. So as I said to Lide, I have no idea. Normally this talk is maybe 35 minutes or something, but maybe I'll get carried away and talk forever, or maybe I'll be finished by 15 minutes. I don't think so though, but maybe I'll be short. We'll see how it goes. Bear with me. It's a little bit of a different thing to do a presentation into a screen, into a monitor, but I'll do my best. So what I want to talk about today is web components, and really like the promise of web components, that you can write your stuff just once and you can use it anywhere, no matter what technology is on top of it. So that's the topic for today. As Kasper said, I should say a little bit more about myself. So this is me. You can find me on Twitter. I'm at Filip Beck, and that's where I handle most of stuff there. So if you have questions about anything or about the web specifically, probably that's the best place to reach me. I work at a company called Collabo, where we built a workplace integration hub. So for the digital workplace, which has all of a sudden become even more relevant for everybody. So that's nice. And I'm a GDE, a Google Developer Expert, which is a global program for experts in their field. And my field is web technologies, and that's where I have my expertise. I also run a local user group called Aarhus.js. So if you're into more JavaScripty stuff and you don't already know Aarhus.js, you should find us on Meetup. We do meetups, I don't know, 3, 4, 5 times a year or something like that. So it's nothing too crazy. So web components are ready. They're the future. Maybe they're even the present. Maybe they're dead. I don't think so. But web components in general are often confused with Polymer. I hear a lot of confusion when I talk to developers around the world about web components. And just to clear that out, at least for those of you here, so web components are a specification, and I'll come into the spec in just a little bit. Whereas Polymer was like the first framework that was kind of built on top of web components, even before web components was really a thing. So it's Polymer was kind of trying to push out what web components could be. But that was a framework, and web components are actually a web standard that ships in all the browsers now. So this talk is going to be, first of all, just the what and the why of web components. It's going to be like a basic tech intro to how do you build web components and how do you use them. And then the two main parts are how do you use web components in your framework of choice. So whether you use Angular, React, or Vue, those are the 3 frameworks that I've brought along today with demos in. And then we'll turn it the other way around and look at how can you use your component from your component library. So from React, or from Angular, or from Vue, how can you take that and use it as a web component? And the why is really what it's all about, right? So it's about interoperability. We want to be able to use a React component inside Angular and make a date picker in Angular and use it in Vue, and use them, vice versa. So the framework of choice should really just be an implementation detail of every component, and they shouldn't have to match. And that's I think that's the promise of web components, and that's what we're going to talk about today. Of course, being actual native components will be even closer to the metal, so we'll have even better performance. And as the browsers mature and get even faster, we don't need to update the framework. We don't need to update anything. Our stuff just gets better and faster. So that's why we want to use web components. I really, really believe in this idea that we should stop Googling for Angular date pickers or React date pickers and just find a date picker and use it in whatever framework we'd like to. So I think that's where we're going to go. Just to show off my product and a couple of use cases for web components. So this is the platform that I work on. This is an example. And actually, we use web components for our extensibility model. So anything where third-party developers can put stuff in our platform that's actually built on top of web components. So that means that they can use Angular, React, or Vue. They don't have to use the same technology as we use. And I think that's a pretty powerful story. And web components are finally happening. I've been updating this schema for the last couple of years, and this January, I think January 15th, marked the last green box, and now we have full support across all the major browsers, and I'm so excited about it. So as you can see here, there are really 4 parts to web components. Web components is kind of a marketing term, really, just to be able to talk about this technology in like an umbrella term. So, but it actually covers these 4 specs: the custom elements, being able to write your own elements that you put in a DOM, like you would a div element or a span element or a p element or something. Then it's the shadow DOM. Shadow DOM is a way of encapsulating your component's view so that it doesn't interfere with view outside, and the view outside doesn't interfere with view inside. So that has long been a big issue on the web, that whenever you put something in your page somewhere, even though it's just a tiny little date picker or something, it might mess up the rest of your site because all styles and stuff are global. And if you have like selectors or something that select like elements on your page, you might end up not knowing, actually selecting something that's within a component of someone else, and we really don't want that. And that's what Shadow DOMs allows us to do, is actually encapsulate all of our components so that they can only deal with the inside of themselves, and everybody from outside can't get access to the inside. Then it's the template element. So an actual DOM element, that whatever you put inside of a template element doesn't render. It doesn't do anything. So if you put a script tag inside of a template tag, it doesn't run the script. It just has the script there for you. And then the template tag has a special property on it called contents, that's actually made for cloning, so that you can very easily clone the inside of the template tag and then attach it to somewhere inside of your DOM, and it'll actually do its stuff and load the images and run the script and all that kind of stuff. So this is a first or like a bare bone templating solution. And then it's ES modules. So if you've been following along with web components for some time, a couple of years ago we talked about the 4th spec as HTML imports, because we thought that was where it was going to go. But with JavaScript evolving the way it did, and with the nature of HTML more as a document language or document format, we turned into looking at ES modules instead. So ES modules are ECMAScript modules, which is the standard for JavaScript. So it's really just JavaScript modules. But the idea is that you can actually import and export functions from other modules, just like you would in lots of other programming languages. So we're getting more and more features into JavaScript that actually comes from other languages, and the language is actually maturing quite a lot. So building a web component is pretty simple. So this is a very straightforward web component. So it's a class. It needs to be a class, a JavaScript class that extends the base HTML element, which is the base class that any element in the DOM actually extends from. And then there are some methods on some lifecycle callbacks for whenever it's put in the DOM, the connected callback and the disconnected callback for when it's taken out, callbacks for whenever attributes change. And then you see in the connected callback, I attach a shadow, and that's how you actually make the shadow DOM. And that means that anything that you put inside of your shadow DOM won't be affected by styles and stuff from the outside, and it won't affect anything on the outside either. Then in line 11, we turn around and we define the element with first the string with the tag name in it, and then the class as the second argument. And one thing to note here is that that the name or the tag name actually has to have a dash in the name, and if you don't include it, it's gonna throw an error at you. But there's a very good reason for that, and that's how we guarantee that nothing the browser will ever come up with, or nothing that's ever going to be spec'd is going to collide with something that you built, and the other way around, that you can't mess up something that the browser already has. All browser elements will never contain a dash, and all custom elements must contain a dash. So that's a pretty easy way of avoiding conflicts that way. And then there's a big confusion on the web, or at least among more or less experienced developers around the difference between attributes and properties on DOM elements. And I think that's there's a reason why, and it's because it's kind of hard to figure out what are the difference and how should you think about them. And the reason why I talk about that, this is that you see here in the code example from before that there's a callback for whenever attributes change, and attributes in the DOM are different from properties. So it's not just properties on the element, it's actually a special thing where you can get a value from an attribute with specific methods for doing just that. If you want to just use regular properties, and I think you should for almost everything, since this is just a regular class, you can just use regular getters and setters to be notified for whenever it changes or whenever somebody reaches the value. So that's pretty straightforward. But I think some of the confusion comes from the fact that this is an HTML line of HTML, right? Where I define an input field. I put in two attributes here. One is type equals the value text, and value equals the value hello, or the string hello. And those are then being passed into a property tree for the element. So if you look at what properties are on an element, it's all of these, right? So this is the same element that we just wrote, and all of this is just standard stuff that gets inherited. But the weird thing about it is that some properties are reflected to attributes and the other way around, and some are only reflected one way and some the other way. And that's just it brings us so much confusion, and I really wish we could change it. But due to the we can never have breaking changes on the web nature, we probably won't ever fix this. So the takeaway regarding that is use properties anywhere you can. Unless you have a really good reason why you shouldn't, then just go for properties. So just the short example here, you see my input field, it has the initial value. If I update the attribute, it updates the value. But if I updated the programmatic or like inherited from the user input, it doesn't change. It doesn't reflect back to the attribute. And then I can read the original attribute value out of it, and it's going to give me a different value than what's actually the value. So I think that's kind of weird. And the weird thing is that it works a different way around with the type. So if you set the type attribute, it's reflecting back to the property, and if you set the property, it's reflecting back the attribute again. So it's just a little bit weird. But the takeaway here is use properties whenever you can. So the final thing I wanted to mention, or almost final thing I wanted to mention here in the basic tech intro to web components, is the slot tag. So whenever you put something, whenever you attach a shadow to a web component, that means that anything that's inside of the component's own DOM, normally we call that the light DOM, is actually not shown. When there's a shadow DOM present, that takes precedence and it doesn't show the light DOM anymore. if you then want to take whatever was in your light DOM and project that into the shadow DOM somewhere, like maybe inside of your template somewhere, so you put your own header, and then whatever people put inside of your element will then go below the header or something. You use the slot tag, and when you put in the slot tag, the content is projected in that way. There are special events for knowing when it's changed, and you can style content that comes in this way via a special CSS selector. You can name slots if you want to, so you can have multiple slots and put them in multiple places in your template. And the final thing is regarding styling. As I said, styling for web components are scoped to a shadow root. So if you put anything inside of the shadow root, it's not going to leak outside, and any rules applied from the outside are not going to be applied inside. And the only exception to that rule are custom properties. Custom properties is a kind of new CSS feature. It's been around for a couple of years, but because of SAS and less pre-built stuff solutions, I don't see that much usage of custom properties. But custom properties are kind of like variables for CSS, and the cool thing is that these variables actually do pierce the shadow root. So that's how we built an API for our web components, that we can actually depend on certain custom properties being passed, and then we can color stuff based on, or we can style stuff based on the value of the custom properties. There are also special selectors for the host tag, which is like the container of the web components when you style it from inside. Slotted, as I said, for the content that's being slotted. And then there's a new spec called parts that's on the horizon, and I think it's going to be super exciting. If custom properties are like a SAS variable, then parts is like a SAS mix-in or like an include. So you can actually pass like a set of properties and values. You can pass those along, and then you can apply them inside of your styling. So I think that ends the tour of web components. And I think if you're following along now, you're good to go. So I want to talk about how we use web components inside of our frameworks. Let me just grab a drink. So web components, whether you build them with whatever framework or without a framework that you want to, the idea is that you can take them and use them from within your framework. So I built a little example, which an example web component. You see here that it doesn't really do anything. It puts in a template. You see the template here in line 6, 7, and 8, right? Where I read a value from like an attribute. I read a value from a property, where I feed in an object that I then read a property on. Then I have a button, and whenever the button is clicked, then we want to actually emit an event, a custom event, that then the container framework can react to. So imagine that this element is like a favorite element or something, so that I get some initial state, and then whenever I'm clicked, I'm just going to emit a custom event saying the favorite has been toggled or something, and then the framework code, that your Angular code or your React code or whatever, could then listen for that event, and then do the business logic and actually fire the request off to the server or save it in the database or whatever. So this is the example element that I want to show, that we want to use from inside of our frameworks. So I want to compare how feature complete the frameworks are in actually working with web components. So I'm going to show how it's done, and then I'm going to show some tests that actually shows you like a score from 1 to 100 in how well it actually works with native web components. So each test is a pass or a fail, and it has a weight to it based on how critical I believe it is. And all the tests are done by the amazing Rob Dodson from Google. It's a project called Custom Elements Everywhere, where you can see where you can follow along as the frameworks update. All these tests are automatically run over and over again, so we can always have a current view. But let's talk about how this looks in Angular. As I said, I'll look at Angular, React, and Vue, or at least I'll start with those frameworks. So in Angular, in order to actually work with web components, you have to add the custom element schema. That has to do with how Angular's compiler works and how the templating knows what is an Angular component and what isn't. If you don't do this, it's going to say this element, we don't know what that is. And of course, Angular doesn't know what it is because it's an element that you built. So add the custom element schema. And then from inside of your component, just a regular Angular component. So all of this is just Angular code. You see in line 7, 8, 9, 10, 11 that I just put in my element. In Angular, to bind to a property, we use the square bracket syntax. So I bind to a property called audience prop, and I bind an object to it. In order to bind to an attribute instead, I prefix the name with attr dot. So as you see here, I say attr dot framework attribute, and then that's going to be an actual attribute binding. And then to listen for a custom event, I put the parentheses around the event name, and then define the function to call whenever the event is actually called. So this is, if you know Angular, this is pretty straightforward, and this is exactly the same way as you would bind to an Angular element. You bind to exactly the same way to a web component. And no surprise, all the way back from Angular 7, Angular has been 100% complete, and all the tests are passing, and it's a 100% score. Then when it comes to Vue, it looks different, of course, because the syntax is different. You see, this is the single file Vue file way of writing Vue, and you see in line 3, 4, 5, 6, 7, 7 that it's more or less the same thing. So I'm putting in the element here. The syntax is a little bit different in Vue. We use the colon syntax to do a binding, and by default it's an attribute binding, and then we can use the suffix of .prop to actually bind to a property. But it's the other way. It's the same thing, just with a slightly different syntax. And for events, we use the @ sign in front of the event name, but more or less the rest of it is the same. And for Vue, all the tests passed as well, and we're at 100%. Then comes React, and in React, you see this is a basic React component, and in React, we see if we do like this, line 15, 16, 17, 18. When we bind to stuff like this in React, it actually doesn't work, and it's because when React doesn't know an element, it always passes content to it as attributes. So there's no way to actually pass a property to a custom element from inside Angular or inside React in a declarative way. Of course, you can do it imperatively and grab a reference to the element and set the properties yourself. But that's not really the point of this demo. The point of this is really to see how it works just out of the box. So you can't bind properties. The attribute binding works as expected. And then there are the custom events. The event listening syntax in React is different, so that you just prefix on before the event name, and then you camel case or uppercase the event name. But you can't have any casing inside of the event name itself. So for our custom event here, that's with a capital E, it doesn't work. So that has to do with how JSX actually works with the compiles the attributes into actual event listeners. So it's a little bit of a sad story, and React passes all the basic tests. That means that it doesn't break React to use web components, but the web components doesn't really work, and I think that's kind of sad. All the advanced tests are broken. These are the tests that are actually broken, but we won't go into that. But the good thing is that Dan Abramov, one of the guys from the React team, or I think maybe the guy from the React team, actually has been talking for almost a year now about React 17 and how we're probably going to do custom elements in React 17. And there was a big discussion going on GitHub around how to do it in a way that doesn't break existing React apps and stuff. Please go to this issue and voice your opinion if you have any, or at least just start so that they'll know that it's important. So of course, for React, you can do it yourself, but that's not really what this is about. What I think to note, though, is that there's this framework called PREACT. So PREACT started out as just being a simpler, leaner way of doing React, and has now grown into its own framework. PREACT actually has the exact same syntax as React. And if you run the same code from PREACT instead, we actually get 100% passed passed tests. So for PREACT, we actually get all the support that we want. And most React apps can just be ported or can just be using PREACT instead. And I'll actually show that in a little bit. So we're at a pretty reasonable place in terms of actually using components, web components inside of your framework. React has a couple of hiccups, and hopefully we'll have React 17 out. They can fix that. But if you don't want to wait for that, you go for PREACT. It's actually a little bit of a smaller version anyway, so it might be a good solution. So the second part of this talk, as I said, is really about how you can then take your component, like you're a developer, you have opinions about what frameworks you like, and that shouldn't matter to anybody else. You should be able to just say, I want to use Angular, I want to use React, or I want to use this and that framework. And then you should be able to just take that framework component and export that or expose that as a web component somehow. And again, the reason why we want to do this is really about interoperability. We want to be able to just write our stuff once and then take it anywhere. We don't want to find the amazing date figure that we've all been looking for, only to realize that that's for React and you're using Angular, so you can't use it. We want to be able to just take it and use it anywhere. Framework should just be an implementation details. The more I say that sentence, the more it makes sense to me. It shouldn't matter how you build your stuff on the inside, as long as people on the outside can consume it. And there are basically two ways of doing this. There are some frameworks that are actually built using web components, and of course they just work out of the box. Those are frameworks like Svelte and Stencil and Polymer, and Polymer is really being replaced by this new little library called LitElement. And I'll actually show you a little bit of LitElement code in a little bit, just to inspire you. But the other way of doing it is actually wrapping your framework component inside of a web component, and doing all the plumbing between them, so that from the outside it looks like a web component, and on the inside it's actually a React component or an Angular component. So we want to be able to just pass regular properties to our custom elements and have that actually feed down into our framework component. We want to be able to use DOM events, that's the native way of doing events, right? So that any framework event on the inside is going to be bubbled up as a DOM event that we can then listen for. We want to be able to support slots somehow where we can project the content that we put inside of our template or inside of our custom elements light DOM, and put that into a shadow DOM somewhere. And then we want to be able to encapsulate styles with the shadow DOM. And that's really what I'm going to be comparing here, is how does this look? How do we score on features? How easy is this to use for the developer? And what's the size of the bundle that will actually come out of this? And I'm not gonna compare how it actually integrates into the frameworks, because it's impossible to compare how change detection and dependency injection in Angular works from outside of a web component, and compare that, because there's really no equivalent to that in React. And the other way around for async rendering and stuff inside of React, there's really no way to do that, or there's no equivalent to that in Angular. So it doesn't really make sense to compare those. So I want to talk about these wrappers. So for Angular and Vue, there's actually official wrappers that wrap the framework components inside of a web component. For React, there are a couple of different community projects, and I just picked one of them because I thought that was the best one. If you know anything, you might you might have a different opinion, and that's fine. I just use one to have an example here. So we will be building a custom button, a button that takes a label in as a property, that uses a slot for some default content, and then it's going to count how many times you click it. So it's a pretty simple element, right? And then it's going to emit a special event that we call action whenever it's clicked. And then we're going to have some local H1 styles and some global H1 styles, and we're going to see that they don't collide with each other. So that's what we'll build. So we'll use it like this. So we'll have the H1 on the outside that should be red, and then we'll put our custom button in with some content inside of it, and then that should show you, that should show you how it works. For Angular, there's a package called add Angular elements, so you can just ng add it to your app, and then you build your component like you would normally in Angular, and then inside of your component declaration, you need to tell Angular to use the shadow DOM encapsulation for encapsulating your styles. That's actually a feature that Angular has as well. But if you don't tell it to, it's gonna emulate it instead. So you tell it to actually use the real shadow DOM by doing it like this. The rest of the component is just implementation details of having the slot tag with the default value in it, showing the number of times that the button has been clicked, I think that's more or less it. The way we then do it is from inside of our Angular module, from our ng module, inside of the constructor, we import a function. In the top you see in line 4, we import a special function called create custom elements that's part of the Angular elements package that we just added before. And we call that with the Angular component with an instance of the injector. That's due to how Angular dependency injection works. If you really want to, we can talk about that later, but that's kind of a boring topic if you ask me. And then that returns like a custom element base class that we can then call custom elements.define with whatever name we want to give it. And then we have to override the ng2 bootstrap method to be empty, and that's more or less everything, and it works right out of the box. So you see that we have a red header and a blue header, and anytime we click the button, it increments the counter. And if we do a selector and actually find our element and then attach an event listener to it, I should probably speed this video up a little bit, but attach an event listener for the action event, and then just log the event to the console, so we'll see what's being emitted. Then we should see when we click the event, or when we click the button again, that we should now get the count every time we click the button. That's how we're going to test that our component actually works. One thing to note though about Angular is that Angular has a very similar thing to content projection that they call ng-content, and it's almost the same. And it's very inspired by how the spec actually works in regards to slots, but it's not the same thing. And I would say just use the regular slot unless you have very good reasons not to. So if you know Angular enough to know why you should use ng-content, then maybe you should do it, but otherwise just go for the slot. That's the native way, and it works, and it's pretty easy. In order to then make the Angular bundle just a little bit smaller, we can turn off the magic change detection part of Angular, which is Zone.js. We do that by telling Angular when we bootstrap our module that you should just use a no-op for NGZONE. And with all that included, with gzip and everything, we have 48 kilobytes of code for our simple component, but it includes all of Angular and stuff. So if you want to build 2 or 3 components, the overhead for the next ones are going to be smaller. But it's pretty nice. I think we're just going to skip that and go right into the view way of doing it. So in Vue, there's a very similar project that's called the Vue Web Component Wrapper. We do npm install just like before to add it, and then we build our component just like we would normally in Vue. So this is just implementation details. So if you want to look at the slides and see how we actually built the magic counter that counts, the magic button that counts and does all that stuff, you can see it right here. And then when you want to actually register your custom elements, it's a pretty common way, or it's a pretty much the same way as we do in Angular. So we get the wrap function from the Vue Web Component Wrapper. We call that with an instance of Vue and with the button or with our custom component, and that returns the base class again, and we call window.custom elements that define with that, and we're pretty much good to go. So there are it's a little bit less obvious how to actually make that work with Vue CLI and stuff. And if you want to just play around with it, I can tell you how to do it. Or you can download. I'm going to link to a GitHub repository at the end where you can download all the source code for all my examples. One thing to note though is that Vue does not support styling. It does not support scoped styling like we did with Angular, and that's due to how the Vue compiler works, I think. And due to the fact that I think the Vue Web Component Wrapper is a little bit less mature than Angular's version of it. Other than that, it works excellently, and everything's great. But it is kind of a bummer that it doesn't work like you would expect. With the coloring, you see that the inside one is just blue, and that's because whenever you put something, let me see if I can go back here. Whenever you put something inside of your style tag here in your single file Vue file here, it's actually going to use Vue's own style encapsulation, just like Angular normally does, and do some magic attributes on the elements and select based on those. And since those don't really live outside of the shadow DOM, and this styling actually doesn't live inside of the shadow DOM, none of it applies to each other. So that's a little bit sad. The rest of the video, I think I already showed you. It works and it's great, but it's the coloring is off, right? And there's really no way to fix it. So I spent quite a little bit of time to see if I could figure it out. But you can't put a style tag inside of your template, and you can't put any link elements inside of your template, and you can't add the styles manually. So there's really no good workaround to do this. One thing is though, so when you want to build it, you call the CLI like you normally would. You tell it that the target should be web component or WC. You give it the name of the custom element that you want to register. And then you call, then you point actually to the custom component Vue file. And I spelled that out very clearly because all the blog posts that I was able to find has this wrong in a way that it actually doesn't work. So this is the way it actually works. With Vue, I think it feels pretty nice. It's pretty smooth. It's pretty light. It's a little bit weird. I didn't show you this, but in the video, when you actually subscribe to the custom events being fired, it's actually, instead of being just a standard event or like a payload coming along, it's actually going to be, the payload is going to be an array where the first index is then actually the value that you're looking for. It doesn't really make that much of difference to you as the developer. It's just weird that they changed it. It doesn't handle styles, as I said, and the only solution they say is you should do some kind of CSS and JavaScript thing to do it. And of course you can do that, but yeah, it's not really the standard way of doing it. The bundle here is pretty tiny, but it does require a global Vue instance. So if you take a look at this right here, you see all combined, it's 36 kilobytes. So it's a lot smaller than Angular already. But if you take a look at the files, the individual files here, you see that the custom button itself is actually only 3 kilobytes transferred over the wire or 3.5 kilobytes. So it's really, really tiny, and I think that's super cool. It does depend on a global view instance though. So if you're using this inside of an application that's already running Vue, there's basically no overhead in doing it through a web component. But if you're not running Vue, then you have to add Vue yourself. Since Vue doesn't know anything about what's actually inside of your custom button, you have to include all of Vue, and you can't really tree shake any of it away because we don't know what's going to be used. So it's a little bit of a different trade-off than what Angular did, but it's pretty nice. Then there's the React way, where we and React is a little bit different from Angular and Vue. In the way that we don't typically listen for custom events in React. Instead, we pass in a callback as a property, a callback function as a property, and then the inner component will call the callback for you. And also React typically only does CSS and JavaScript anyway. So yeah, we should take a look at how that would work in our example. So for React, there's no official wrapper. As I said, there are a couple of different projects, and I'm just going to look at the one that's called Web React Components, and don't confuse that with the other components. I confused those for a little bit. I spent more or less an entire afternoon trying to build a demo with one of them using the other one's documentation, and that was not easy. But it's sadly not very maintained. It looks a little bit like it was a prototype, and then they kind of just left it there. But I actually think it's kind of nice, and it works really well. So I think you can use it. But of course, judge for yourself, right? So it has a register method to wrap and register like the other ones do. For React, typically when you want to use something like the content projection feature, you spread out props.children into your template. And you can do that if you'd like, but what this framework actually does is it's just going to put a slot tag for you whenever you do that. And I think you should just write it out yourself instead then, because that gives you the ability to actually put in a default value if there's nothing in the slot. You can't do the styles natively either in React, so you can do the hack and actually set the inner HTML from the JSX template. But that's kind of bad and dirty. And then it ships in an ES5 way, which is weird because custom elements are only supported in browsers where that actually supports ES6. So it's a little bit weird, and it requires a polyfill to then run and stuff. So I actually made a fork of it that just runs ES6 and works out of the box, and you can use that. It's inside of the repo that I'm going to link to. The way you use it is you install the dependency, then you build your React component like you normally would. The only thing to note here is what I do in line 21, where you see I set the styles inside of the JSX template, and that's kind of bad. It's kind of a bad way to do it, but it works, and it gets the jobs done for now. But that's probably not a very scalable way of doing it. Then it looks a lot like the other two, where you import a function from the special library that then wraps your component and gives you back an instance that you can then register. One thing to note though here is that they actually take care, or they're actually even more explicit about what properties should be kept in sync from the web component or from the custom element to the React component. So you see the third argument to the register call here is an array that has the string label in it, and that's actually because label is the property that we want to keep in sync. So I like that it's very explicit in what properties to keep in sync for us. I think that's very nice. And then the fourth argument you see is an object which has a binding between a React style callback and then the web component style custom events of doing events up and down the tree. So I think that's actually a very nice and explicit way of saying from inside React, you should just write React like you normally do React, and then we'll do a little bit of translation to actually make this work. So I think that's very nice. So the slide I was going to show here is that for React, we're at 42 kilobytes of code, which is kind of nice. But then I went on to see, PREACT solved all my problems before. So let's see what we can do with PREACT. So as I said, PREACT is this, started out as a project where they wanted to make a much leaner version of React. So they took away some of the old, support for older browsers, and took away some, edge case APIs and stuff, and made a very small library. So if we take PREACT, we npm install PREACT instead, and then inside of our build config, we tell them that anywhere anybody asks for React, we should just give them PREACT instead. And if we do this and run the same build again with the exact same code, we actually get down to a much better solution size, bundle size for our React web component. So I think this is actually getting pretty close to being useful. And if we sum it up, we see that as a consumer of web components, Angular and Vue both score, along with PREACT, 100% on the consumption score. React is a little bit, or actually quite a lot behind. For the features, the wrapping features of web components, Angular is a little bit better. Vue and React don't do the style stuff, and PREACT, it's actually the same. It's actually the same thing. Then for the developer experience, I think they all they have all more or less the same experience as a developer. If you ask me and myself, I actually kind of prefer the React or PREACT way because of the explicit nature of how you actually tell it what properties should be found, and what do the whole matching of callbacks to DOM events. And if you look at the wrap or the bundle size of the wrapping, you see that there's really no contest here. PREACT just kicks everybody else out. And if I was going to build a standalone web component today, I would go for PREACT, absolutely no choice, if I wanted to use a framework. And that's really the question, or the note that I want to end on. So I'm getting close to the end now. Do we even need frameworks now? Or can we just use web components alone? And I think there are a couple different answers to that question. I think the web standards are getting there. Of course, it's a standard race, so the specs are ahead of the browsers typically, and not all of the browsers support all the parts of parts of the spec that we really want to use. So there are, like I mentioned, the parts CSS feature. And there's some stuff around how we do accessibility and how we do form participation and stuff that's very badly supported, actually. And I think we need probably something still to be able to actually handle that. But I think if we can use web components and put a little bit of sugar on top, like we do with lit element, with stencil, or with svelte or something, I think we actually have we have a pretty nice feature set of building blocks to build a small little library for ourselves. Then of course we need some helpers below, like utility libraries for doing state management and HTTP and stuff. And that's actually it's getting closer to how people typically write React, right? So web components themselves are more or less just a replacement for what React comes with, and then you still need all the rest of it. So you still probably need Redux or something to handle state management, and you need Axios or something to handle HTTP requests, and there are multiple mini libraries to handle or utilities to handle all those cases. And I really like that the platform is actually at a place now where, like, the framework part of it is less necessary than it was a couple of years ago. And I just wanted to show you an example. So the next slide is going to be some more code. And what I want you to notice is not really the specific or the syntax of this code or something. It's more like seeing that this is actually kind of close to how you would write a React app or an Angular app that we've seen. but this is written with lit element, which is like a super simple, I think it's like 3 kilobytes of code wrapper around web components, and it gives you more or less all the features that you want. So if you look at this is built with this is in TypeScript. Lit element is very much built for TypeScript, and you see that we have some similar things. We have our class, like when we do it ourselves, and then we register it with a decorator on top of it instead of calling it imperatively. And we do the same things for properties that we want to keep in sync. So when you see we have the add property in line 9 and 10, that means that those properties, whenever they change, they're automatically going to re-render our template so that the template is always in sync. And we've just fire regular DOM events for anything. And this is actually a piece of code that could just replace the React app that was just the element before, which was 50 kilobytes of code. So I think this is pretty nice. And of course, if you look at something like this, since it's actually web components, the consumption is 100%. We have all the features that we want, and the developer experience here is pretty great. And the bundle size of the wrap, even with all the helpers, is still actually a little bit smaller than PREACT, even though PREACT is getting there. This is a really nice way of working with web components. As I said, the platform still has some gaps to fill, especially around parts and form participation, but stuff like scoped registries, being able to have custom elements that have the same name but be different parts of the page with like different registries. I think that would be a nice thing. And polyfilling is still kind of hard in some of the older browsers, and I think we need to fix that in some way as well. So I think web components and your framework, they complement each other really well. So with this approach that I'm suggesting here is, when you build like in your component tree, when you think of your leaf nodes, maybe just start building them with web components today. Then you can use all your framework logic and to build all the higher order components and all the logic. And then whenever you want to change your app, then you don't have to change all of your UI because they're web components and you can take them anywhere. I think React still has a little bit of ways to go, but PREACT seems to be the real deal, and actually does more or less all that React does as well. We still need a little bit of glue for most applications, but we can make this happen, and I think we will. I think we'll see that over the next couple of years, more and more frameworks are going to be built on top of web components, because they will be smaller, they will be faster and more efficient. And I think if frameworks like Angular and React will want to be relevant in 5 years, I think they need to look at this as their way of implementing their own framework. So this is the link here in the bottom to all the code samples, and of course I'm going to be sharing the slides afterwards, so you can take them. And that's more or less what I had for now. I think with the break, I think we managed to stay more or less on time. We have 20 minutes for question or something, or a discussion, or whatever you want to do. Of course, find me on Twitter. Follow me there. That's a great place to find me anytime that you have questions.
Thank you very much, Filip. So I think to get the most out of this Q&A session, I think we should do it like this. So if you have any questions, maybe type them in the chat, and I will call out your name, and then you can take the microphone by pushing the space bar on your computer. You should be able to. Otherwise, I'll help and I'll unmute you. So you're welcome to put on video as well. So do any of you have any questions for Filip? No questions?
I'll need some liquors at least.
Oh, Casper has a question. Go ahead, Casper.
First, I just want to say thanks for a very deep and interesting talk. Not being a web developer, I have to admit that I probably did not appreciate all the details, but it definitely compared to web components talks I've seen over the past couple of years, it seems like it's finally coming together, which is especially the kind of table you showed with all the green dots to say like we're now fully stable on all major browsers, which kind of leads to and you also kind of alluded to it in your last comment, like are we looking into a future without these major frameworks dominating? Are we going to be more kind of free to do custom things, but we're going to have this amazing catalog of like the best of the best for anything you want, like the best calendar picker, the best whatever contacts list, the best. Is that how we're gonna? How is that gonna change the whole landscape of web development?
Of course, I know the future. So any questions about the future, I'm always available. I hope that's where we're gonna go. There are some initiatives out there around, building the global like component libraries and stuff that are built on top of web components so that you can use them in all your frameworks. I think it's just webcomponents.org, which is the place to go, where there's lots of documentation and there's a ton of great examples and great components that you can just pick and choose and use from. And then I think we see more and more of the bigger companies actually investing in this. So in the new reference implementation of material design for web, for Google is built in web components. I know that IBM has their own component set internally, which is built on web components, which is also a pretty huge team, and it's spread across many projects. And I think maybe one of the biggest projects out there is Salesforce. I think the entire Salesforce suite, they announced that they're from now on, they're calling them Lightning components, but it's actually just web components. And I think that's super exciting, because that means that I can write my component with React and have it work inside of Salesforce, and I don't need to be able to understand their weird code, because they used to have some really weird code. And I think that's where we're gonna go. Yeah, so I answered a lot of questions in that one. But I think I'm pretty excited about it, because I really don't want to go back to the days where I always had to type in jQuery date picker to find the date picker, because I needed to use it from jQuery, right? And I think we're at a place now where the technology is actually ahead of a lot of the community in this, and I think we'll absolutely catch up.
Are there some learnings from the jQuery kind of era of web development, where that was kind of the one, for good or bad, right? Because there were almost too much going on in too many directions.
I think web components is actually an example of that. So a lot of the stuff that came into the JavaScript spec in the late 2000s was actually very inspired by jQuery and what jQuery did, because they solved real developer use cases. And I think that's what web components are now. Like, it's very inspired by how people have been using frameworks for the last 5 years. So the whole idea of a component model is not as something in a spec committee thought out. It's React and Angular, and those frameworks, they came up with or at least they brought a component model to the web, and then that's being standardized, and so I think that's actually what's happening, and it's fun to see how they take stuff from each other, like with the content projection stuff, and Angular actually called their own feature content projection, just like the spec one, and if you ask me, they caused a little bit of confusion with that, because when you call your stuff the same thing as the native thing, and it's not the same thing, that's maybe not the right way to do it, if you ask me, but yeah, I think they rub up each other, and I think the web component is actually a great example that the web specifiers, or the W3C and the community groups handling that, are actually listening to what real developers actually use and what needs out there. But I think the the idea of the extensible web, that's what we talk about a lot in the web community, is that the platform should give us some pretty low-level primitives, and then frameworks should be built on top of it. And now that we've seen that all the frameworks have been building a component model for themselves, let's bring a native component model to the web, and then the frameworks can just be sugar on top of it. And that's really what web components are.
I guess picking off not the second to last bit, if you are a developer right now, you're looking at like, I like doing web stuff. Like what should you double down on to be ready for this future that you're describing? Like because you'd be tempted to get knee deep in some framework and become an expert on React or Angular or whatever.
Yeah.
But is it more back to basics? Like is it like a new kind of paradigm we're looking at, or is it the same old skills just with a new?
I mean, what I've been teaching everybody for the last 5 or 10 years is really how you build apps on the web with a component model of something and a tree of components and passing data and all that stuff. And I think that's going to be relevant probably also in a couple of years. Maybe the underlying technology or the framework is going to change, but I think we're going to be building apps the same way. I would, like, when I hire developers, and I do that every once in a while, front-end developers, I look for people that know the platform. Because frameworks are absolutely going to change. Like, we don't use the same frameworks now that we did 5 years ago, and in 5 years we're probably going to use different ones again. But the platform is going to be the same. So anything that's actually in the web platform, that's where I would suggest investing my time. But on the other hand, what gives you bread and butter or butter on the bread, that's what we say. What puts butter on the bread is really what you can do today. And I would say in the market, if you look at the global market, I would absolutely go for React or PREACT. I think that's the dominating framework of these days. But that's gonna change, I'm sure. Like in 5 years, no one will remember or we'll talk about React like we talk about jQuery now. Like, do you remember when everybody was using that? And like, I think it's going to be different in 5 years. So go for the platform. That's the only thing can't change or won't change.
Any other questions?
So
no questions? Casper, go on.
Off, at least, yeah. Well, if I don't have any, I'll just make some up. So all of this coming together, as you say, like with full support and probably communities growing up around these and it becoming more and more the kind of the first way you go. What's the next frontier? Like, what's in web technology in general? Like, what's the next big thing that needs to be resolved to really unify? Like, so the dream is to write code that you can use across all of these.
Yeah. So I think the next frontier is inside of Google, we refer to it as bridging the app gap. When it comes to when you look at the apps on your phone today, I suspect that 80 or 90% of them don't really do anything that needs the extra 5% of performance that you get from a native app, and they don't need to be 100 megabytes of code or something. And that's really what the web can give you, right? We can give you something that's very easy to deploy, where there's no Google or Apple that controls what you can get out and when and all that stuff. I think the web has some great opportunities in regards to that, and I think in a couple of years the consumer won't know the difference between what's a native app and what's a web app, and the bridging that gap is I think what everybody on the web platform is working on these days. So that's all the way from installability and discoverability of your app or of your web app to like the actual APIs that we have on the native platforms, like some of the newer ones that have actually landed in Chrome, mostly on Android. I think are APIs like getting the contacts out of your phone, writing files to disk and reading from disk, and all that kind of stuff. And I think that fits in a picture where everything can just be the web. It doesn't have to. And I think that fits the story that Google tries to do. Google has this fun duality because they do Android on one side and then they do the web on the other side, and in a way they're kind of competing for the same market, right? And then they do Chromebooks where they say you can just use the web for everything, and now you can install Android apps on your Chromebook, right? So I think it's a little bit different, but I think that's just a temporary thing while both platforms catch up to each other. And it's obvious that Android are trying to catch up with the web in terms of a first install and in terms of discoverability and that kind of stuff. And the web is trying to catch up with Android and iOS and all the mobile platforms in regards to hardware access and stuff. And I think they will eventually, both of them, catch up. And I think the consumer shouldn't know. It should be an implementation detail, right? Whether you choose to do it with web technologies or with like a native technology, you should just pick whatever you want, and that's fine. So I think that's the next frontier, the next bridge to gap to fill is Google. Inside Google or inside of the Chrome team, we refer to it as Project Fugu, like the fugu fish, which is very delicious but very dangerous if you don't know what to do with it. And that's really how we think about the APIs, because giving developers access to like hardware stuff or your contacts and stuff from a privacy perspective, it's very dangerous. And traditionally we've been talking about the web as kind of a sandbox, right, where you go to a website and you're sure like it's safe because it can't do anything outside of that. And then if you want to be able to open those doors, actually, like we have to really, really think about how we do it in a responsible way, where the consumers actually trust us to do it. But I think we'll get there.
It is a whole perception thing that has to change alongside that. And I think definitely security, but also performance, right? There's a lot of new things coming into Android for restricting, background access to network and location and things like that to optimize battery and increase awareness of essentially companies harvesting your data for whatever purpose.
Yeah, so that's what a lot of the discussions, a lot of what's holding back a lot of these efforts are actually privacy concerns and like hardware, battery, and that kind of stuff. It's the same concerns for Android as it is for web, right? Because we don't want to be able to have anybody write an app that just listens on the consumer's position or microphone or whatever when they're not aware of it, right? So we want to find the right balance here, and it's a hard thing to do. But I think some smart people are working on it, and I think we'll see more and more stuff landing.
Any more questions, guys? This is like exclusive access to one of the top minds on web technologies in Denmark, so I think you should make it.
So now is your time.
I think you put your details in there, Philip, right? People can hit you up on Twitter, and
Twitter is the place to find me. I usually answer on Twitter pretty fast, and I like to talk to people.
We know.
Did you manage to buy a ticket? I just bought a ticket to I/O just before they, I think 2 days before they closed the country and everything. I bought a flight ticket and a hotel and everything. So that's so if anybody wants to has my name and wants to go in a week.
I wonder what they're going to do with the release, like the whole news cycle around it and all that. If they're going to still,
they're going to live stream some of it, maybe.
Yeah,
we'll see.
All right, good stuff.
Right.
Well, thank you so much, Philip. Sorry, Lida, you can close it
I
off.
was just going to say what you're saying. Thank you so much. And also to the rest of you, I'm putting mine and Casper's email in the comments. So if you have any suggestions for future topics or speakers, then feel free to reach out. And yeah, thank you all for coming, and thank you, Philip. Hope you had as good a time as we did.
I did. I'm working on a talk, as I said to Casper. I've done it once that does, you know, some of the newer stuff with Bluetooth and stuff from the web. So I'm building a bike computer for the web that actually takes power data and heart rate data and all that stuff off some sensors. And I think it'll be fun. I'll do a live demo one time at a GDG meetup again. That'll be fun.
Cool. And let us know if you need some test people.
Absolutely.
We'll pen you in for the some time in the new semester. I guess would be a good time. Maybe September.
Yeah, probably.
Cool.
Yeah. Cool. Okay. Wishing you all a great evening, guys. See you soon. Hopefully, also in real life.
Good to meet you, everybody.
Bye.
Bye.
Bye.